Hello friends, this is PS Rasa and I'm going to cover integration topic as part of advanced level maths, mainly, the AS maths part 1 as part of this News Rasa YouTube channel. So if you have not subscribed to our channel already, please hit that subscribe button now and share this education series videos with your friends. Also, please send me your comments and questions using the channel contact details shown, and I will try to answer them for you if you would like me to cover any specific topic in the future. So please comment below and I will try to cover it next time. Thanks. So let's crack on with our today's topic. It's integration as part of advanced level maths. So with integration, I'm sure most of you have already done integration and would like to maybe go through it again. This will be a different type of integration, compared to, mainly in terms of the method. So what is actually integration? So when it comes to integration, you're trying to find out the area under the curve. So say, for example, if you have a curve like that and you're trying to find out the area between the curve and the x-axis. So when you integrate this, the quadratic function, so say, for example, y, equals x squared plus 3x plus 5, then you get the integration done, for this graph, and then you get this area under the curve. Under the curve and the x-axis. So that is the main purpose, of the integration. So let's have a look at, the types of integration, we're talking about. So in this education video, I'll try to cover the indefinite integral first. And then we can cover the other parts of the integrations, in the future videos. So if you're going to define a function, so say, for example, in this case, your differentiated function. So again, if you have done differentiation already, that will be quite handy, to understand what I mean by dy by dx. If you haven't, then I'll do that later, and then you can, come back to this. Now, so if this is the differentiated function, then we are trying to integrate this function to get the integrated function, right? So the first step is to realize that x to the power of n times dx, and then we are trying to integrate on both sides. Okay, so if you are trying to integrate on both sides, yeah, how do we get that? So integral of dy is y. Okay, and then we are going to integrate this x to the power of n. So with integration, what we do, we basically increase the power by 1, right? And then divide it by the new power, all right? And then we also have to put a plus c. I will explain the details, why we put plus c, next, okay? But this is the integrated function, okay? So I hope, you get the basic definition of that, right? Now, one other thing, we have to define that n is not equal to -1. Why? Because if you put n as -1 here, it becomes 0. So that divided by 0 is infinity, right? Yeah. So we want to avoid that. So this is the integral of dy by dx is equal to x to the power of n. So you can apply this formula to do all the integrations later, right? Okay, so that's that. And then I mentioned about, okay, having the, okay, why do we need the x? I mean, the plus c here. So say, for example, if we have like two functions, like say y equals x to the power of 3, right? If y is equal to x to the power of 3, then if you do the differentiation of that, yeah, dy by dx, yeah, would equal what? 3x to the power of 2, yeah? So again, we will go through that in differentiation later if needed, but I assume that you have already done this, right? So now we have another function. So let's call it, the other function as say y is equal to x cubed plus 5, okay? So if it is x cubed plus 5, and then if you differentiate this, yeah, what do we get? 3x squared. So as you can see here, we get, the same expression, when we differentiate x cubed, and also when we differentiate x cubed plus 5. All right, so we get the same 3x squared. So when we try to integrate this, normally we would have what? So say, for example, we would have dy by dx is equal to 3x squared, right? And then I'm trying to integrate this, so if I use the formula shown on the green, here, so integral of dy is equal to what? 3x squared dx. All right, then this is going to be equal to y, and that is going to be what? If I take that and then I increase the power by 1, so x to the power of 2 plus 1 over 2 plus 1. And then remember, I have to put a plus c. Now, if I don't put the plus c, then I will end up with, just 3 and then x to the power of 3 over 3, which is simply equal to x to the power of 3. Now, what will happen, so if you end up with just x cubed only, then this is okay. But this doesn't work for this one. So this is the problem. All right. So we will have to somehow, rectify this. And this is why we introduce the plus c at the end. So as soon as we integrated it, we start introducing the plus c. So the plus c, when we put a particular coordinate, onto the integrated function, right, for x and y, then we can work out the c. Again, we will look at that, later. Right. So I hope you understand the basic here, in terms of how to integrate it, and then to get a generic function, which is in green here, and then to apply that to, do further integration with some examples. Okay, so the next one I'm going to look at, is to find the y. So the question here is, so say, for example, as an example, question is what? Find y for the following, right? Okay, so I'm going to do some examples, so that you get the idea, right? Yeah, with the worked examples, right? So find y for the following. All right, so the first one we are going to do is basically what? dy by dx is equal to x to the power of 4. So this is the differentiated version of the function, and then we are trying to do the integration. Okay, so how do we do that? So again, like I said, you just cross multiply to make it into this form, and then you start integrating it, right? So you get y, because integral of dy is y, and then integration of x to the power of 4. So that is going to be what? X to the power of 4 plus 1 whole thing divided by 4 plus 1, and then plus c. So the answer would be what? X to the power of 5 divided by 5 plus c. And that's it. So that's the answer, for the integration of x to the power of 4. So that's one example. All right. So if I clear that, and then the second example I'm going to look at, is what? So we're going to have dy by dx is equal to 2x cubed. So this is slightly different, function. Okay, but let's see how we do the integration to it. Okay, so we do dy equals 2x cubed dx. Okay, are you with me so far? Right. So we do the integration for both sides. Okay, so integral of dy is just y, and then we have, when we come inside the 2x cubed, you can separate it as 2 times x cubed, right? So then we do the we increase the power of x cubed, right? So that's going to be x to the power of 3 plus 1 whole thing divided by 3 plus 1. All right, and then don't forget to put the plus c, please. Okay, right. So then we have our x cubed over, sorry, x to the power of 4, because 3 plus 4 is 3 plus 1 is 4 over 4, right? Plus c as well. And then we can sort of simplify this, right? 2 and 4 can be simplified by 2. So we get this. And then our final answer is going to be just what? X to the power of 4 divided by 2 plus c. And that's the final answer for the second example. So I hope, you can just slow down the video and then try to understand it, bit by bit, step by step. But it's very important that you do go through the stages, without rushing and making careless mistakes. Because even if you make, if you follow the steps and then, if you make a mistake at the end, you have the steps to come back and rectify your errors. Okay, so that's why it's very important. Every stage, from this explanation is very important, right? All right, then. So let's have a look at another example, which is example 3, right? So we do have dy by dx is equal to 6x plus 2x to the power of minus 3 minus x to the power of half. Okay, so we have a larger expression. Okay, so we've looked at, on example 1 and 2, slightly different but single term. But here we have 3 terms, to integrate. So it shouldn't be a problem. What we have to do, we just have to split by terms, right? And then integrate them by, separately. All right. So that's it. So again, we want to do the dy by dx. Yeah. So we can do 6x plus 2x to the power of minus 3 minus 3x to the power of and dx. Okay. And then we are going to do the integration. So this is the integral sign and it's an indefinite integral sign. Okay. There is no limit to it. Okay, so what do we do here then? Right, so if you integrate dy, then you get y, right? And then I'm going to integrate all these, the 3 components, yeah, by parts. Okay, like separately. All right. So for the first one, I have 6 times, and if it is just x, then you have power of 1, correct? So you do 1 plus 1, and then you bring the power to the bottom as well, right? And then plus 2 times x to the power of minus 3 plus 1 over minus 3 plus 1. So we basically bring the new power to the bottom. All right. And then the next one is what? Minus 3 times and x to the power of half plus 1, and then half plus 1. And then also we'll have to put the plus c as always. Okay. Right. So then we try to simplify them. Okay, so we're going to do 6 times x squared, because 1 plus 1 is 2, and then 2 at the bottom, right? Plus 2 times x to the power of minus 2 over minus 2, and then here we have minus 3, and then x to the power of 3 over 2 divided by 3 over 2 plus c. Now we can start simplifying them, right? Yeah, so if you simplify that, you get 1 and 3. And if you simplify this, you get minus 1, right? And then if you simplify this, you get 3 gone, so you get just 2 at the top. All right, so our final answer, again, you shouldn't have any problem simplifying fractions. By now this is advanced level, right? So I rushed through that because I assume that you know how to simplify with fractions. Okay, so if you have any questions, please contact me and I'll go through it for you. Right, now we have 3x squared, and then because we have a minus 1 at the bottom, so this is going to turn into minus, right? So minus x to the power of minus 2, right? And then we have we can then simplify this, so we're going to get 2 minus 2 x to the power of 3 over 2 plus c, and that's going to be our answer. Okay, so that's a bit medium level, I would say. And but this is still doable. Yeah, so how do we do that? Step by step. So don't forget the steps, please. Okay, so I hope you wrote all these down, right? Okay, then, right, then we are moving on to the fourth example, right? Okay, so let's have a look at the fourth example. Okay, so with the fourth example, how do we do that? So the fourth example is what? Find the equation of the curve. Yeah. So find the equation of the curve when dy by dx. So we need to find the equation of the curve. So basically y is equal to something. All right. So dy by dx can also be written as what? F dash of x. Okay. Because we know that y can be written as what? Just f of x. So it's basically a function in terms of x, or just y. Y is also a function in terms of x generally. All right. So that is a relationship. So if when you do the differentiation of y, you get dy by dx is equal to f dash of x. So it's kind of a shorthand notation to say it's a differentiated version of f of x. Okay, right. So I'll clear this. So that's the definition here, so that's what I wrote as what dy by dx is equal to f dash of x. All right, and the function, the differentiated function, is given as, yeah, say x squared minus 2 whole thing divided by square root of x. Okay, and then they also give you 4 comma y as coordinates. Yeah, we will see why they give you that, because we need to find out the c, which is the constant we introduced when we do the integration, right? So if we use 4 comma 5, then we can work out the c. All right, so that's why they give you this, and then I'll go through that once we have integrated this. Yeah, so I'm going to write this time instead of dy by dx, I'm going to write it in terms of f dash of x, right? So if I integrate f dash of x, and the one here is going to be what, x squared minus 2 over square root of x, and dx. Remember, we always have to put dx here, right? Right. So if you integrate f dash of x, you get just f of x, right? If you differentiate f of x, you get f dash of x. So if you integrate f dash of x, you get f of x. All right. So similarly, like, if you differentiate y, you get dy by dx. And then if you integrate dy, you get y. Okay, so similar. Right, so then we are here to do the integration. But before we do the integration, we have to do some adjustments, here, right? And with the function, given function, right? Yeah. Why? Because that is not in the standard form that we would like. All right. So we'll have to do some simplification here. So what we do is we split the functions like this. Okay, I'm just writing the bottom one as x to the power of half, because you know that square root of x is basically x to the power of half. Yeah, and I'm writing it for a reason. All right, so because I get this, right? Yeah, right. Then I have to bring them all like numerator. So x squared divided by x to the power half would be what? X to the power of 2 minus half, right? Minus 2, and then x to the power of minus half. Yeah, why? Because when you bring the denominator to the numerator, when the bases are the same, the powers are subtracted. So I'm just subtracting 2 minus half, and then there was nothing on the top, or maybe 0, x to the power of 0 minus half is minus half. Okay, then even then it's not the final version, because we just need to simplify a little bit. So we're going to have 1.5, yeah, minus 2x to the power of minus half dx. Okay, I hope you're with me so far, right? And this is still integral of f dash of x. Okay, then I'm going to do the f dash of x, and I'm now ready to integrate it, right? So I have x 3 over 2, because 1.5 is what, 3 over 2, yeah, plus 1 whole thing divided by 3 over 2 plus 1. Okay, and then minus 2 x to the power minus half plus 1 whole thing divided by minus half plus 1, and then I introduce the letter c here, right? Then I'm going to do a little bit more simplification here. So I'm just going to clear okay, so I'll probably do a line here, right? Then I'm going to write this here, right? So I do have what, f of x is equal to x to the power, so 3 over 2 plus 1 is what, 5 over 2, isn't it? Yeah, 5 over 2. And then at the bottom I do have 5 over 2 as well, right? And then minus x to the power of minus half plus 1 is half, isn't it? Yeah, so minus 2 and then x to the power half, yeah, over half at the bottom, right? Because minus half plus 1, and then plus c, right? Then I can simplify this even further. So I get 2 over 5, because 1 over 5 over 2 is 2 over 5, right? So x to the power of 5 over 2. Then minus 2 divided by half is 4. So 4x to the power of half plus c. So that is f of x. Okay. So I hope you got this up to here, right? And then I'm going to do the substitution. So my f of x is y, right? So this is my y value is equal to f of x, yeah? and that is my x value. All right, so I'm going to put 5 here. All right, so maybe I'll do it in a different color, just to differentiate. Yeah, just to differentiate between the sections, and I'm splitting them, even though it's one question. We are doing it this many steps, because you need to understand it properly, right? So we're going to have 5, so f of x is equal to 5, and then I'm going to put the x as 4 here, right? So 4 to the power of 5 over 2 minus 4, and then times, so these are all times in between them, yeah, 4 to the power of half, and then we have the plus c. Okay, happy with that? So 5 is equal to 4 to the power of 5 over 2 is what? 32, isn't it? Yeah. So you can again, work out using the index you have already done, or maybe use a calculator, but get the correct answer. So this is going to be just 32, and then minus 4 times 2, because 4 to the power half is 2, equals that. All right, so 5 plus 8 minus 64 over 5 is equal to C. All right, so if you look at that, 2 times 32 is 64 over 5. Bring it to the other side, becomes minus 64 over 5. And then you have minus 8 here, bring it to the other side, becomes plus 64. So I'm just rushing it, to get the final answer. And then I'm coming here. So my C value is equal to what? Is going to be simply 1 over 5. Okay, so my final function, which is f of x, yeah, is equal to what? So I'll probably write it a little bit further down. So my final function, I'm going to write it in a different color. All right, so that's going to be f of x equals, and then I'm just going to substitute the value for c, and I'm leaving the rest as it is. Yeah, so it's 2/5 x to the power of 5 over 2, and then minus 4x to the power of half. Okay, instead of c, I'm going to put plus 1 over 5. All right, so that is my final answer, and this is the equation for the curve. All right, that's what. Okay, so if you start from d bar by dx, you end up with, okay, or f dash of x, you end up with f of x, which is the final equation without the plus c, only in terms of x. Okay, f of x in terms of x. So that's the end of today's session, in terms of integration. So I hope you found it interesting. So okay, friends, that's the end of the session for today, and we will meet again soon with another important A-level topic. Okay, before you finish, please do not forget to subscribe and share these videos with your friends, so that they can benefit as well. So remember, maths is fun, and get it done. All right, so stay safe and healthy, and we will meet again in another video very soon. Thanks again. See you.